All right, so here's where function analysis with pieces gets exciting because we have an expression, a function expression here, where you've got this bracket. And what that says is that f of x is broken up into multiple pieces. And the pieces are defined by these intervals here. So there's a split. And essentially what we're doing is on a number line, if you were to have a number line, from -1 is where this function starts. And then there's a break at 2. And then it continues and it stops at 5. And so for everything solid dot from 1 to an open dot on 2, we use the definition negative x minus 1 squared. So any input that I want to find, like 0 or -1/2, anything in there, I use this definition here. But anything right of there, I'll use purple, we're using the definition of x minus 6. So anything with a solid dot in purple there of 2 all the way to a solid dot of 5, any number in here, we use the definition x minus 6. So depending on what you're trying to evaluate, here we're just looking at f of 5, we would use those definitions based on what's happening over here in your domains, your separated domains. So this problem is a little bit shorter than I would like it to be because there's just literally one plug-in value. It would be nice to at least plug in a couple. So I'm still going to make one up and plug in a couple. F of 5, you look at your piecewise definition, and I'm going to clear this up because it's all written on. On our piecewise definition, I focus on the where is 5. Well, 5's here. And so the only thing I have to worry about is 5 included? Yes, it is, because that's an equal to sign. Less than or equal to means that 5's okay. That's why I put a solid dot right there. And so what that means is I use this function definition, that line x minus 6, to evaluate what would happen if I put in a 5. Well, what I then do is put in a 5 right here. So f of 5 means it's actually 5 minus 6 as a result. 5 minus 6 produces a -1, so that is my output for this particular problem. Now I'm going to get a little bit more exciting, and I'm going to plug in 2. I want to find what's f of 2. I know that this problem doesn't call for that. It's not going to work for this particular one, but that's okay. F of 2 is a little more exciting because it's on the split, and that's most exciting because I got to have you see, where does it go? Well, it's less than or equal to x here, and then x is less than but not equal to 2 there. So what that means is, on what I did here was I put the purple dot, and it went with my x minus 6. So f of 2 uses the x minus 6 definition, not this quadratic over here on the left. So if I wanted f of 2, I would do 2 minus 6 and get a -4 result. That would be my f of 2. Let's do one more where I have to use this left part. Let's find the f of 0. If I wanted to find f of 0, I look back at my piecewise definition, and I look at the split up here, and I just figure out what interval on which 0 is. Well, 0 is between -1 and 2, which means this interval requires me to use the quadratic definition. So I'm plugging in a 0 to the quadratic. So if I want f of 0, I would make it negative, and then I plug 0 in for x, -1 squared, and then you work that out to find your result. Well, 0 minus 1 is -1. -1 squared is +1. But then you have this -1 on the outside. What actually happens here is it's negative times a +1, which is -1. Too often students will see this -1 here, and then they go negative times negative is positive, and they give me a positive result at the end, not doing the order of operations correctly, where you've got to square it first, and that'll get you that +1 in here, and then times it by a negative to get -1. So new function here, we've got 2 different pieces. And again, if you think about it, on a number line, you split it up from -3 to 2 and then 2 to 5. But here we're just doing a one-off, so let's just follow the lead here. When I'm plugging in 2, I just look, where does 2 end up on these 2 definitions of the domain? Well, 2 is not included on that line. It is included on this line. I kind of drew over it. It is included there. So what that means is any value that works in here, I use this definition. So to find f of 2, I make it -2 times plug in 2 minus 2 using this linear definition here, and then work it out and simplify. So -2 times 2 is -4. -4 minus 2 is -6. And that is my result of f of 2. So it's just a matter of figuring out which line does it go on and then plug it into that line. All right, on this problem, we're finding f of 3. We have a constant function and then a linear function up here. Our job is to, again, focus on these piecewise rules over here of which x values go into where. Any number from -1 to 2 uses the rule, close dot on -1, open dot on 2, uses the rule of x plus 3. Anything right of that with a open dot also, and then all the way to 5 with an open dot, uses the rule of -4 would just be the output. Well, we're looking for 3. Well, 3 lands right here. So whatever values are between 2, not included, all the way to 5, the output, no matter what, is -4. You don't have to do any work at all in this one. You just kick out and identify that it goes and becomes, the output is -4. A lot of students they don't like these negative, like when you just have a constant, because we try to multiply, people give me -12, but it's just whatever that value it is, that is the output. But on this problem, I have 3 pieces to my definition with 3 different rules over here on the right. One number I'm evaluating. And the nice thing that I like to ask these questions for is because 3 shows up in 3 places. So it's really sorting in our mind to see, well, where does 3 actually go? Well, if you're noticing, it's not included here on the top rule. It's not included on the bottom rule. It is exactly equal and allowed. This rule only happens and only applies when x is 3. So it's telling you right here, the output, -5, is for whenever x is -3. Well, x is -3, or sorry, is 3, not -3, is 3 here. So my output is exactly what the rule tells me it is. It is -5. There's no other place to put it. It just works with that one location. All right, now we're going to evaluate a function where we're plugging in 0. And again, what's happening here is that there's a definition for x is less than -2. So we have a solid dot and shaded that way for using the rule 5x plus 6. Well, we're looking at 0, so we don't use that one. But then over here, we have this rule that says we are solid dot greater than 1. We use the definition -x minus 3 squared. Now, this might prove to you why it's valuable to go ahead and just kind of plot that to recognize what's going on, because what we're doing, I meant to put a 1 right there. What we're looking for is f of 0. Well, 0 is right here. I don't have a definition for 0. 0 doesn't fit in my rules over here on the right. So what that means for me is, since there's nothing happening function-wise, I didn't get a rule for that, that means that that part of this function is not defined. So we say undefined. There's no result that I can get. So it's not defined. There's nothing I can say about it. It's between spaces of my rules here. 0 lands between these two values. All right, here we are looking at -1. And what's interesting about this rule is it's saying use this parabola definition for everywhere except when x is -1. And then it says when x is -1, use -6 as your output. So the quick version is the answer is -6 because it tells you that it's -6 when you plug in -1. But what's really happening is you have this parabola, and then when x is -1, you have an open dot, and then it's piecewise redefined somewhere else is what's going on. It's kind of interesting. But quick result is x is -1, so the output right away is -6. All right, on this one, we've got 3 pieces. And last time we just had where it worked out it was just this easy one in the middle. But this time, we've actually got to pay attention to which one of my rules does it work for. Well, one actually appears as an endpoint, so it's pretty clear. We jump right here. It's 1 is included in this top rule. So out of the 3 options, we're just using the top rule to evaluate for 1. So we plug in the 1 for the x there in the -3x, so we put the 1 there, plus 9, which works out to be -3 plus 9, which is 6. So that is my output when the input's 1 out of those 3 rules, just using the top one. All right, so we got 3 rules again. This time, the 1 is not showing up as an endpoint in here, so we have to do a little bit more thinking. It's all about 4 here. So 4 is the hinge. and we are less than 4 because we're evaluating over here at 1. So we want to pick out of these options the one that says that less than 4 is where I am, which is this top rule. And so the top rule is a quadratic. So to find f of 1, I plug it into that quadratic of negative, parentheses, put a 1 for the x, minus 2 squared minus 3. And now there's a couple errors that people make going forward. The negative and stuff, people make mistakes. But 1 minus 2, this should get us negative 1. And then that's going to get squared. Don't lose your negative sign out in front because people see that way. They may go plus, plus. Don't do that. Negative 1 squared is positive 1. And then you bring this negative 1 down times that positive 1 minus 3. So the final result should be a negative 4. All right, one last example here. We've got 3 pieces. We're evaluating at negative 5. Now, what you'll notice is that in our 3 pieces, negative 5 does show up. It's right here. So what people do is they get excited. It's like, oh, there it is. And they go and run and plug it in. But be careful. Notice the alligator, the inequality symbol, does not have an equal sign. It's less than. So negative 5 is less than x, which means that this actually does not include negative 5 in the definition for this function. This function is not defined at all for negative 5. So our result should be undefined. So be careful when you see the value at the end, make sure it is actually included by alligator inequality symbol here. To get it to be in there, you would need this symbol to have the equal sign. Since it doesn't, it's not, and so we have it undefined instead of being defined.